This is another Peterson podcast about science, and today we're talking all about pulleys. In fact, this is my introduction to the pulley lab, Lab 35, WM Lab 35. So for this, you will need the handout that is WM Lab 35 or a blank piece of paper upon which to do your lab write-up. But let's start at the very beginning. We're going to make a fixed pulley first, and to do that, you want to attach a pulley to a ring stand, or in our case, we're going to use the ropes that I hopefully have hanging from the ceiling in the lab area. But basically, you want to make a fixed pulley so it's going to pretty much stay motionless, hanging from somewhere, be it a ring stand or a ceiling. And you want to feed through it a piece of string or a piece of rope, and you can typically you're going to attach something to the end of the rope, and if there's a loop on it, I would keep that loop there and just take the free end and feed it up over the pulley and then attach something to the loop. Usually we use a book. Once you get it built, what you want to do is measure how far you move your hand. Okay, I'm right here. How far you move your hand, that's your input distance, and should be recorded as such, input distance. And then measure how far the book travels. That, of course, is your output distance. Use a meter stick, and how far you move it's entirely up to you. I would make it, I don't know, 10 centimeters, 20 centimeters, whatever seems appropriate. Maybe use nice round numbers to make your calculating easier. But whatever you do, for each trial, you want to move it the same distance. So for example, if you pull down 10 centimeters here, have your partner measure how far it goes up over here. Do it a couple of times if you have to. And then attach a spring scale, and you want to measure the force required to lift the book. And when I say that, I mean with the pulley. So you'll attach a spring scale right here, and just see how much force that is. That's your input force. It goes right here. And then you want to measure the weight of the book. In other words, the pulley is lifting the book. How much is it lifting? Well, the weight of the book. So just suspend the book with the spring scale. And that would be your output force right here. And then you simply do the calculating, just like we've been doing in class. You want the ideal mechanical advantage, the actual mechanical advantage, and then we're going to calculate percent efficiency actually two ways. One, using the work in by the workout divided by, workout by work in divided by 100. And then number 7, you're going to calculate percent efficiency again, but this time you're going to divide mechanical advantages. We really want to make sure that whatever answer you get right here for number 6, it really should equal exactly what you get right here for number 7. Okay, so if that doesn't work out, make sure you seek some help. So next I want to show you a video of me actually building the fixed pulley, because I know using a picture can sometimes be a bit, well, misleading because the pulleys don't look exactly alike. However, you'll notice the mess in the background. I didn't think about the background when I shot the video, but this is my workshop in the basement. So here we go.
Go.
You're recording? All right. So first we're going to make a fixed pulley system. And to do that, you can find the rope that looks like this hanging in the lab area, and you want to, just so you're not tying a bunch of knots, use a paper clip to attach a pulley just like this. Here, I'll disconnect it so we can see the actual starting point. So you'll find a pulley, paper clips, and just kind of twist the wire together so it's like that. And then we want to attach a rope to it, and the rope should already have in it, if it doesn't you can make one, but it should already have a loop of some kind. And definitely want to do the other end through the fixed pulley. Feed enough line in there, you can work with it, and then attach your book to the loop with, guess what, another paper clip. And that's our fixed pulley. Okay. Now we're going to do part B of this lab. We're going to build a movable pulley. And to do that, I apologize, the directions are a little unclear. It says to make a movable pulley, attach a pulley to a ring stand, use figure B as an example. Well, figure B is a good example. However, you really want to attach right here the loop to, well, the ring stand, or in our case, the rope suspended from the ceiling. And notice the pulley is way down here now, and you attach whatever it is you're lifting, in our case a book, directly to the pulley. And so you're going to pull up in the same direction that you're lifting. So let me zoom in on that. So attach the string to some fixed surface or to some fixed point, and then feed the rope through the pulley like this and suspend the book from the pulley. You'll pull in this direction, and then of course you'll have the book moving in that direction. And once you've got that all set up, it's a matter of lifting the book, oops, and again, measure how far you move your hand, that's your input distance, and at the same time, record how far the book travels, that's your output distance. Now, I think it's helpful, again, to pick nice round numbers. Use 10 centimeters, use 20. I would move it a nice round number, but make it pretty far, because the further you move it, the less, a little bit of, like a centimeter won't make such a big difference. The percent of air should be less. Then, again, use a spring scale. See how much force you're actually pulling on the rope, and that might require a little bit of creativity because the rope doesn't have a loop on it now, and so you have to sort of wrap it around the spring scale hook and then pull it, see what the force is, and then, again, find the weight of the book. It should be the same, by the way, as the weight of the book in the previous trial, in Part A. But check it just to be safe. And now we're going to show you an actual video of me building that particular pulley. Okay, so now we're going to make our movable pulley, and to do that, you start with the paper clip, and you want the loop now to be on the paper clip, not the pulley. And I think it's helpful if the loop is on not just one hook like that, because you can tell with enough force that might actually pull off there. Try and get the loop on both. So it should look like that. If you need to zoom in, you can. Thank you. Now the movable pulley, as the name implies, is movable. So you take the pulley and feed the rope through either end. And it's easier with a partner. But once you get it looking kind of like this, if you let go, it sometimes just turns the wrong way like that. We don't want that. So hook another paper clip on, and then of course we're going to lift a book again, and just get it so it's the right way, like that. And finally, part C, we're going to make a movable pulley system, also known as a block and tackle, the picture of which is right here. And it's a little bit of a combination of the first two pulleys. But the first thing I think one should do is attach a pulley to the rope or to some fixed part, suspend a pulley. And then you'll want a paper clip right down here and attach the loop of string to the paper clip. Then feed the free end, the non-loop side, through another pulley. And at this point you might want to attach the book, otherwise the the pulley is going to turn the wrong way, but then feed the string back up and over the initial pulley that you suspended in the first place. Requires 2 pulleys and 3 paper clips, and of course the book that we're lifting. So the directions, they don't really tell you how to build the block and tackle. I'm hoping that the picture I just went over with you and the video I'm about to show you would be enough. But just like we've done in the other two, while lifting the book, see how far you move your hand, that's input. See how far the book moves, that's output. And then use a spring scale. Look at how much force it requires to move the book. Look at how much force the book actually weighs. And all that information gets recorded right here. Once you've recorded your data, go ahead and calculate ideal mechanical advantage, IMA, actual mechanical advantage, AMA, and continue with your work in, the work out, percent efficiency calculated both ways. Remember, your answer here should be exactly equal to the answer down here. If not, then there's something wrong in the measuring or there's something wrong in your calculating. But seek some help. I'd be happy to help. And then, of course, number 23, what are some advantages of using a pulley such as this one in this activity? Okay, so here's a video of me now building that with the actual supplies you're going to use. Okay, this is our third pulley. It's a movable pulley and a fixed pulley, and quite honestly, it's the most difficult of the three to make. So I would start with this. Hook your paper clip on and put a pulley onto your rope just to suspend it there. And then you will need another paper clip. This one actually requires 3 paper clips. At the bottom of the pulley down here. Okay, now so this one's going to use 2 pulleys. So there's one pulley, it's the fixed part. Now comes the movable part. And so you start with it like this. You're going to attach the book down here. And it's easiest if you start with the fixed side by attaching this onto the hook. So it looks like that. And then through the other end, and it doesn't matter which way, you feed the rope through. So this is a combination of the fixed and the movable. Okay, now that's about halfway done. And at this point, it usually is easier if you get the book attached, but I don't have a partner to work with, or my partner is holding the camera. So I'm going to let go. It might fall the wrong way, and it does. And now you want to feed the rope through the top pulley. And this is pretty good. Obviously this is turned the wrong way, so I'm going to hook on the book for our, to hook on the book I need another paper clip. There we go. And now we have a movable pulley and a fixed pulley. So that concludes our Peterson podcast for today on how to build pulleys. And remember to build the fixed, then the movable, and then combine the two to make our block and tackle.